Okay, so now we're working through every question 2 of all the pure papers available. Now, take logs of both sides. So we're going to get ln 43 to the power p minus 1 equals ln 5 to the power 210. Now we've got to use our power laws, so we know that 3p minus 1 ln 4 equals 210 ln 5. Now we want p to be the subject, so we divide out by ln 4. So we're going to get 3p minus 1 equals 210 ln 5 over ln 4. Now it's quite nice, we can just plus 1 on both sides and divide out by p. So p is going to equal 210 ln 5 over ln 4 plus 1 all over 3. So p equals 81.6 to 1 decimal place. Now when it asks you to leave it in exact terms, you have to leave it in terms of ln. Okay, so question 2, you've got a speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time left when it left the ground. You've got the results in the table below, and then it says estimate the length of runway used by the jet to take off. Now we haven't done this yet, but this is going to be, imagine the air underneath the curve is going to be the distance, isn't it? So we're using the Trapezium Rule, which was before. So that the length L, part A, is going to be, can we see we've got steps going up in 5, so that's the H bit going up in 5s, so we have 5 over 2, y0 is 2, plus 2 times 5 plus 10 plus 18 plus 28, close bracket, plus 42, and work that out on your calculator, and that's going to be 415 meters. Now part B, imagine if we're going to get a trapezium like so. Here it's going to be an overestimate because the area of the trapezium is or will be greater than the area under a curve. So as soon as you spot that is the Trapezium Rule, this question is not too bad. Okay, so this is a very nice question. Find dy dx. We should be hitting full marks on this, and that's, we can consider that at plus 7. So that's going to be 2x minus 2. Now remember, this is minus 24x to the power of half. So that's going to be times by the power. That's minus 12x to minus a half. The second derivative is going to be x. Now minus times a minus is going to be a plus, so plus 6x to the minus 3 over 2. Verify that C has a stationary point when x equals 4. That's when dy dx equals 0. Good form to state that. 2x minus 2 minus 12x to the minus a half. Let x equals 4. So we're going to get 0 equals 2 times 4 minus 2 minus 12 to the 4 to minus a half, and that equals 0. Equals 0, and then equals 0. So dy dx equals 0. Therefore, stationary point. C. Do the nature. So when x equals 4, use the second derivative. Equals 4 plus 6 times 4 to the minus 3 over 2. I suggest you substitute it in to get your method marks, which equals 2.75. Now that is, so the second derivative is greater than 0, so we write therefore it's a minimum. It's a minimum point. So find the length OD. Do pause the video and read the question. So we're trying to find the length of OD, which is this. So the arc length equals the radius times theta. Now we know the radius r equals 3, and arc length CD equals 3, and AOD is 12. So we know that 3 equals r times 0.4 in radians, so r equals 7.5. So that radius equals 7.5, so OD is in fact 7.5. Now part B, find the area of the shaded sector here. Now if you imagine this is 180, pi equals 180 in radians, so angle AOB equals pi minus 0.4. Now AOD is 12. AOD equals 12, so AO must equal 12 minus 7.5, which equals 4.5 centimeters. Now the sector area. Now normally in a area of a sector of a circle is the angle over 360. But in this case we have it in radians, so it's over theta over 2 r squared. So theta is pi minus 0.4 over 2 times 4.5 squared, which equals 27.8 centimeters squared, to 3 significant figures. And that one is quite easily done, and this is hopefully helping to build up your skills and your confidence in the pure papers. Every mark counts, so let's make sure we clean these up. Okay, so this is a spot the mistake type question. So look at both sides and see where error lies. Now we can see here they try to divide both sides by sine theta here, hence it went to 2, but as we know from part A, cos theta over sine theta is in fact 1 over tan theta, which is cot theta. So you would say that they divided by sine theta, and that was a mistake because that does not equal tan theta. Obviously write that as a sentence, that will give you a 1 mark. Now BI, explain why this answer is incorrect. Student B gives theta equals minus 26.6 as one of the answers. 2 cos theta equals 2 sine theta. And if you plug in the calculator, cos theta using minus 26.6, you're going to get a positive answer, and then 2 sine theta, when theta equals minus 26.6 is negative. So that's your explanation. Part 2, explain how this incorrect answer arose. So they squared both sides here, right? So when you square both sides, they've got rid of a negative answer and everything becomes positive. So when both sides were squared, everything became positive. Now let's look at question. You have figure 1 shows a plot of the curve with equation y equals cos x, where x is measured in radians. And on the opposite page is a copy of figure 1. Okay. Copy and use diagram 1 to show the equation cos x minus 2x minus a half equals 0 has only one root, given a reason for your answer. Well, that means cos x equals, this is part A, equals 2x plus a half. So the y-intercept is a half. So c equals a half, and the gradient m equals 2. So if this is 1, that's the half, and at 1 we're going to get 2.5, and at minus 1 we're going to get this. So if we draw a line here, you can see only one intersection. Therefore, one real solution or root, one real root. B, use a small angle approximation for cos x, estimate the value of alpha to 3 decimal places. Now, what do we remember? We need to remember the cos theta approximation. So cos theta equals 1 minus theta squared over 2. So we're going to get here 1 over 1 minus, x squared over 2. We're just going to substitute into this equation. Minus 2x minus a half equals 0. Let's multiply everything by 2. So we get 2 minus x squared minus 4x minus 1 equals 0. Let's rearrange that to plus the x squared plus the 4x and minus the 1. So we're going to get 0 equals x squared plus 4x minus 1. And now we solve that by using the quadratic formula, I guess, or completing the square. Probably quadratic formula will be easier. It's only 3 marks. Completing the square will be quite easy as well. So that's x plus 2. 0 equals x plus 2 squared minus 4 minus 1. 0 equals x plus 2 squared minus 5. So we can get plus or minus the square root of 5 equals x plus 2. And also we're going to get minus 2 plus or minus root 5 equals x, but do it to 3 decimal places. And where can I write that up here? So x equals 0.236 and x equals minus 4.236. But look at the diagram, that's your right one, and minus 4 is not a solution. So that is your correct answer. Okay, so this is vectors in 3D, and A has this position vector and B has this position vector, and that's C. Now point D is a point that AB equals BD. It says find the position vector of D. And so we've got to find out what AB is, because that equals BD. So AB is going to equal B minus A. So that's going to be 4I minus 2J plus 3K minus 2I plus 3J minus 4K. Do you put that in a bracket? Now it depends how you want to write that. You can write that in vector form, but I know that is going to give us 2I minus and then minus 5J plus 3K minus 4 plus 3K minus 4. So that's minus K. Well, it's minus minus actually, so that's plus 7K. Now it might be easier to write that as 2 minus 5, 7. Now what's the next bit? Find the position of D. So if you think the vector D, let's call it VD, is going to equal VB plus this 2 minus 5, 7. We know what B is from above, which is this. So that's going to equal 4 minus 2 and 3 plus 2 minus 5 and 7. So it's going to give us 6 minus 7, 10. Sometimes it's easier to write out like this so you don't make a mistake. So that's going to equal 6I minus 7J plus 10K. Now we've let to go over this, but we should be okay to use this as a revision source. So it says AC equals 4 the magnitude of AC. So the magnitude from A to C. So we need to remember A to C is actually equal to position vector C minus position vector A. Okay, so that means we get here A minus 2 squared, because we're doing the magnitude, plus 5 minus 3 squared, plus minus 2 minus 4 all squared has to equal 4 squared. So we get A minus 2 squared, that's going to give us plus 4, that's going to give us plus 4 equals 16. So we get A minus 2 squared, we take away the 8 on both sides, equals 8, square root the 8, so A minus 2 equals square root of 8 plus or minus, and here it says A is less than 0, so let's do A equals minus 2 plus or minus root 8, so A is plus 2, here we're plusing 2 over, so A equals 2 minus root 8, which is 2 minus 2 root 2. Okay, let's look at this question, which we will improve at when we do vectors. Now P, Q and R lie on a straight line, that gives us our straight line. Q lies 1/3 of the way from P to R, that gives us this. So this is 1/3, this is 2/3. Now imagine that's little p, that's Q, and that's R. Now we have to show that Q equals this. So we think P to Q equals minus P plus Q. P to R, let's write it over here, equals minus P plus R. Now P to Q in terms of P to R is 1/3 that, because of this 1/3 here. So PQ equals PQ, so this equals this, so we do minus P plus Q equals 1/3 minus P plus R. Now we're just going to try and rearrange that in terms of Q, so we're going to plus P on each side. So Q is going to be equal P minus 1/3 P plus 1/3 R. Now that simplifies to 2 over 3P plus 1/3 R. So Q equals 1/3 of the r. You can see here that 2/3, that makes 2p, and we've shown this at the start